we've seen that rational expressions are algebraic expressions that have denominators. So we've seen something like this. This is a rational expression. Now, they really do work as fractions. They are algebraic fractions. That's what they are. And so we're going to see how to combine them. And it's going to follow all the same principles that we saw with regular fractions. And so when I struggle, like if you wonder what's happening here, it's just going to follow. Just remember how fractions worked, and we're going to follow all the same rules. Now, we're going to get kind of a gentle introduction here in this section before we move on. But here's a reminder of how this worked. If you had fractions, the denominator is the slices. This is sliced up into 18ths. So if I'm going to be able to add these slices together, they have to be cut the same way. Well, these are. So if that's the case, you can just add up the top. So I've got 12 over 18. Now you can reduce this. Now I'm going to show you this just the one time. So I'm going to break these down. So I'm going to show you the factor method, which I showed you in the beginning of the course. So that is 12. It breaks into this. And this is 18. So I'll show you this method and then show you the faster way. So, okay, so if I had 12 over 18, you don't remember, I broke it down into its factors. You can cancel the matching factors. So the 12 over 18 reduces to 2 over 3. I had a 2 left on the top and a 3 on the bottom. Now another way to do this is that you could see that they were both divisible by 6. So I divided the top by 6, I get 2. Divide the bottom by 6, I get 3. Now that's usually how I'll do it here, but if you didn't know, the factor approach will always get you there. Alright, I got a couple more of these here. Now these are all sliced the same. So the denominator is how the pie is sliced. So these are cut into 16ths. Well, they're the same, so I can just add the top, and I'd get 12 over 16. Now you could do the factor approach, but these are both divisible by 4, so this is going to reduce down to 3/4. These are both over 10, so I'm ready to just add them up. I'd get 4 over 10. These are both divisible by 2, so I can divide that down and get 2/5. Now that's exactly how it works in the world of algebra. Now I know this doesn't seem to be that clear, but this is all a number, and they have been sliced the same. I know this doesn't make sense to us, but they've been sliced by 4y minus 3. But the point is the rules will be the same. So the denominators here are identical, so we can just add up the tops. Now, and keep the bottom the same. So now that we've come this far, what we're going to do is see if anything can factor down and we can cancel. But remember, there's a plus and a minus here. So these are all one number. That is a big number. All of that in the circles is one number. So if you wanted to factor that down, you would have to, or cancel it down, reduce it. You'd have to be able to factor first because of the additions. So there are two groups here. You cannot cancel these y's. They are all part of a bigger number. They're like a single digit. Okay, so these have the same denominator, so we can just add up the numerator, keep the bottom the same, just like we would with regular fractions. Now nothing here cancels. There's nothing to factor. I cannot cancel the x's. They're digits and part of bigger numbers. Now here, I can add the tops because they still have a common denominator. I get x plus 1 over x minus 2. You cannot cancel the x's. They're all parts of a bigger number. Okay, now here we're going to be able to do some factoring. So my denominator is the same, so I'm going to just add up those numerators. And I get this. Okay, now let's factor the top. Now I'm looking for two numbers that make 12 and add to get 7. So it's going to be x plus 3, x plus 4. Okay, now they're factored. These are a match. That is the same number with all of that, and it's been factored. So I can cancel a matching factor, and my final answer is just going to be x plus 4. Okay, you can always pause it. Let's see, do I have more of these? Okay, I put them both on the same screen, so pause this if you want to try. I'm going to get started, especially if you feel a little shaky on your factoring. Okay, so over here I've added the top and the bottom stayed the same. Now can we factor this? And I believe we can. We can do x plus 7, x plus 2. Now it's been factored. That is a matching factor. That's all matching, so the whole number can cancel, and x plus 2 will be our final answer there. Okay, here I'm adding the numerator up. Alright, now let's factor this down. So x plus 3 times x plus 5. If you're not sure how I'm doing that, go back to the old videos. Now, these are now matching numbers, and they've been factored, so this can go, and x plus 3 is my final answer. Now, it doesn't change with subtraction. As long as the denominator is the same, nothing changes. Now, we got to keep an eye on subtraction because of something in particular. I'll get to that when we get further. But so, the denominator is the same, so subtraction works the same. Just subtract the top over the bottom. Now we know how to factor this top, so n minus 10, n plus 10 over n minus 10. Now that's a match, so I can cancel those. It's been factored in a match, so I can cancel it. N plus 10 is my final number. So we do this again. The denominator is the same, so I can just add them up. Well, in this case, subtract them. Now this factors. This is the easy one. Perfect square binomial. Factored it down. That's a match. So the denominator matched, so I could just put them together, subtract them. Now this may seem a little different. This is factorable too. This is perfect square binomial again. You could factor it down like this. Agree with that? Now I've got the match since it's been factored, and 2x plus 5 is my final answer. Okay, now here's where things get tricky. If I have subtraction, remember, anytime we're doing this with polynomials, this negative sign is going to have to go to everyone who follows. So this is going to become minus 2y minus 24. If the student's going to miss it, they're going to miss that the negative carries through. Okay, now let's check that we can factor this. Two numbers to make negative 24 and add to get negative 2. So that's y minus 6 and y plus 4. Now I'm doing that quickly, but go back to the factoring videos if you need help. Okay, so this is a matching number, and the top's been factored, so it can cancel out of there. Okay, so we'll just be careful. The denominator is fine. It's the same, so I can put it together. Now this negative is going to carry through, make that negative n and negative 12. Now we can factor this. And that can now cancel because it's a match. Okay, pause it if you want to try. God, it's going to change every sign that follows, all of them. The denominator is a match, so we're good there. Now I'm going to factor this down, so it's going to be, because this is a plus 8, I need two numbers to make positive 8 and add to get negative 9. That's a little tricky sometimes. It's this. Now those are a match. Okay, this doesn't change even though now we have trinomials. The denominator matches. That's a weird number, I know, but that is a match. So we're going to follow all of our regular rules. So I'm just going to write down that matching denominator. Now this negative is going to go to everyone that follows. So it's like, I'm going to write it above here, negative 4x squared minus x plus 9 is what this has changed it to. So let's combine like terms. This guy matches with this guy. I have 5x squareds. I'm taking away 4 of them. I have 1x squared left. Now I have negative 7x, another negative x, it's negative 8x. I have plus 3 and plus 9. I've got plus 12. Okay, now this is an unusual type of problem, but let's factor it down just to see if we can get something to cancel. Now I can't cancel x squareds. This is one giant number because of the minuses, and all of it on the top and the bottom. I cannot just cancel x squared. If I want to be able to cancel this, I have to factor first. So let's see if it can be done. That is a factor for the top. And that's a factor for the bottom. So yeah, they did intend it to be. Now that it's factored, those are matching factors, and my final answer is x minus 2 over x plus 3. Okay, the denominator matches. Now we're going to get to the point in the next few videos where the denominators don't match, but they do here, so we can just carry that denominator over. Now we're going to just subtract. I'm going to show all the changed signs up here. The subtraction changed every sign. So now let's put together like terms. Those are like terms. So I've got an x squared. Got negative 11x minus x, that's negative 12x. I've got 8 and 3, that's 11. Now let's factor to see if anything can be done. Again, I'm going quickly, so go back to the old videos if I'm losing you here. But that's how they each factor. X minus 1s have been factored and they are a match. They can go, and my final answer is x minus 11 over x minus 2. Okay, I think this is, last one. So if you want to try one, pause it, and this is the time to do that. They have the common denominator, so I'm just going to write that down. I'm going to change this because it's subtraction and change everybody's sign. 6x squared minus 5x squared gets me x squared. Got minus x and negative 11x, that's going to be minus 12x. 20 and plus 7 is plus 27. Okay, so let's factor. So all factored down. Got my match. My final answer is x minus 3 over x plus 9. Okay, now all of these had a common denominator. Now we're also going to get to that place where if we don't have a common denominator, we've got to make it match, which is going to be a much more challenging problem. But first of all, just make sure you've got this. If you've got a common denominator, keep it the same and just either add or subtract the numerator. Once you've got that, see if you can factor. But just be careful. You can't just factor individual numbers. You have to have it. You can't cancel individual numbers. You have to have factored first, and then you can cancel identical factors.